So to choose between two assets in which neither dominates the other, we're going to use utility preference. And the idea is for every asset, we have a expected return and we have some risk. We can plug those into this utility function, and given something about a person, we can figure out how much utility this person derives from this investment. And we can compare the utility of two different investments, and we're going to assume that the investor will choose the investment that gives them the higher utility. So the amount of utility you derive from an investment depends on the expected return, less half of the variance, which is the risk, multiplied by a risk aversion parameter A that weights the risk. And so capital A is this risk aversion parameter. And risk aversion varies across individuals, and we saw a little bit of this when we were talking about the coin flip example. Remember that none of us would flip a coin for $1,000, win 2,000, earn 2,000 for heads, 0 for tails, but we might play for 900, 800, 700, 600, 500. At some point when you decide that the risk-return trade-off is reasonable, we can see that this varies across individuals, and this risk aversion parameter is going to be the measurement of this. We'll talk about how we come up with A in a minute. So for now, risk aversion varies across individuals, and for now, risk aversion entirely defines an individual. Person is A equals 2, a person is A equals 4, a person is A equals 7, and that's the only information I have about a person is their level of risk aversion. And the greater the value of risk aversion, the more you dislike risk, you are averse to risk. And it measures the extra return a person needs to be compensated for incurring more risk. So how do we determine this? Well, we do it badly. It's seriously flawed. And there's a risk aversion questionnaire from the text that I've posted. There's many issues, including behavioral biases and framing of questions and recent events that can affect this. We'll talk more about determining risk aversion later, but for now, risk aversion will be given, and the way to think about this is you sit down with your investment advisor or you log on to the website, and the website asks you a series of questions, and you pick a number between 1 and 10. And it's ordinal, meaning that we wouldn't say 4 is twice as risk averse as 2, but 4 is more risk averse than 2, and 5 is more risk averse than 4. I remember a bunch of years ago I was working with a not-for-profit here in town, and we were hiring a investment manager for an endowment, and we went in to see this this investment advisor, and the investment advisor said, "Well, what's your time horizon?" And he said, "This is an endowment, so infinite, whatever your biggest number is." And he said, "Okay, so what's your level of risk aversion?" And I said, "Well, you can ask me a bunch of questions and we'll pick a number between 1 and 10. And he said, "Oh, no, between 1 and 100. The point is that the scale doesn't matter. The difference between these things doesn't really matter. It's the order that matters. So for now, risk aversion will be given. And so for any risk, for any individual, we can compute the utility derived from an investment and compare that to the utility derived from a different investment given these 3 inputs. And the first is the expected return of the investment, the second is the risk of the investment, and the third is specific to the investor, that level of risk aversion. So, again, for now, investments are defined by 2 parameters, and an individual is defined by a single parameter, which is just the risk aversion.